So students, today I'm gonna make my first attempt to do this video tutorial for you. And today the problem that we're going to start is 2002 Calc AB free response question 3. Okay, so today we're going to do the problem in 2002 Calc AB free response number 3. Here says an object moving along the x-axis with an initial position of x of 0 equal to 2, the velocity of the object at time greater than 0, which makes sense, time is always positive, is given by v of t equal to sine pi third t. So here is our initial equation, and we need to make sure that we remember that. And there's a initial position information, which I believe every time you see that, you want to remember that the relationship between velocity and position is that in order to get to a position equation, you have to take the integral, actually antiderivative or indefinite integral of velocity. And remember, when that happens, you usually end up with a constant, integrating constant. And in order to find out the value of the constant for this particular situation, you will need the initial position information. So let's take a look at the first problem. The first problem says, part A says, what is the acceleration at time equal to 4? Now, acceleration is just is a derivative of the velocity. So I'm going to go ahead and solve that problem. So part A. Part A says I want to find acceleration. So acceleration, A of t, is equal to velocity derivative v prime of t. Now, since our v prime is equal to, now remember, v is sine pi third t. So then we say, well, what's the derivative of the sine pi third t? Well, the derivative of sine of something is cosine of something. So it's cosine pi third t. But we need to multiply by the derivative of the inside function, which is right here. And the derivative inside function is pi third. So we end up with pi third cosine pi third t. And here the problem says we want to find out the acceleration at t equal to 4. So A of 4. So A of 4 gives you pi third cosine pi third times 4, which is pi third cosine 4 pi third. Now in trigonometry, you learn that 4 pi third is 120 degrees. Cosine 120 degrees is negative 1/2. So you end up with pi third times negative 1/2. That gives you negative pi 6. So this is our answer for part A. Now moving on to part B, and I want to bring the question back again. Part B note here says, consider the following two statements. Statement 1, for time that's between 3 and 4.5 seconds, I was assuming it's in seconds, but regardless, between 3 and 4.5, the velocity of the object is decreasing. Statement number 2 says, between 3 and 4.5 in the time frame, the speed of the object is increasing. Now here is asking whether these statements are correct, either one of them or both of them are correct. And we need to provide reason whether statement 1 or 2 are correct or not. Now here it brings out a very interesting concept and lesson that I believe that we need to remember, especially dealing with problems of particle motion problem, particle moving problem. Is this idea of velocity versus speed. Now you remember velocity has to do with the magnitude of the movement as well as direction. So it is possible for velocity to have negative velocity, negative value. Speed, on the other hand, is always a positive value or absolute value of the velocity. Now, this becomes quite tricky. For example, so this begs for another lesson. I wanna use another sheet to talk about it first before we go back to this idea. Now here I want to develop a chart. This is a chart that you need to remember, and this is a chart for velocity and speed, acceleration, and how we interpret that. So what I'm going to do here is I'm going to put V right here to represent velocity, speed right here represents S right here represents speed, A right here represents acceleration, and I'm going to put some notes, and I'm going to draw a little table. Now, there are several scenarios. If velocity is positive, now remember, speed is always the absolute value of the velocity. So speed is always positive. That makes sense. Now, we also have a situation where velocity can be negative. But remember, speed is always a positive value or absolute value of velocity. So speed is always positive. Now, in the first scenario, and now we can say this is the first case, and then this is the second case. For under the Roman numeral first case, right here, Roman numeral 1 case, we could have two possibilities for acceleration. Now, if we have a positive acceleration, that means what? Well, that means that the velocity is increasing. That makes sense. Now, if velocity is positive, that means, and the acceleration is positive, that means v, the value of v, is getting bigger and bigger and bigger and bigger on the positive side. So, for example, if v is 0 to start, and then the next moment is 1, the next moment is 2, speed is going to go from 0 to 1 to 2. Now, 0 to 1 to 2, for v, that means increasing. For speed 0 to 1 to 2, speed is also increasing. So that makes sense. Okay. Now, what if the acceleration is negative? Well, think about this. If velocity is positive, say 3, and the acceleration is negative, so the next moment will go from 3 to 2, 2 to 1, 1 to 0. So velocity is decreasing. That makes sense. Now speed, if similarly, because it's an absolute value of the velocity, so let's say start with 3, and then the acceleration is negative, so the next moment goes from 3 to 2 to 1 to 0. So speed is also decreasing. Now notice over here in the scenario 1, the increasing decreasing really has to do, it depends on the acceleration. So positive acceleration for positive velocity and positive speed is making them increasing. Negative acceleration making both of them decreasing. So this is this is a common sense. Now scenario 2 makes it somewhat not so intuitive. Let's take a look at this. Let's start out with acceleration that is positive. Velocity is negative. Now, let's say we start out with -3. Negative 3 as velocity. -3 as velocity, acceleration is positive, that means it will be increasing. So you go from -3 to -2 to -1 to 0. So velocity is increasing. That makes a whole lot of sense. Now this is where it gets tricky. Now remember, velocity was -3 to start with. So go from -3, -2, -1. Velocity is increasing. But speed is the absolute value of the velocity. So instead of saying -3, -2, -1, we end up with starting with +3. But this goes from -3 to -2, -1. This will go from 3 to 2 to 1 to 0 with the positive acceleration. You see, because the speed is the positive measure of the velocity. Does that make sense? So now, if you go from +3 to +2, +1 to 0, with the because of the positive acceleration, because of the negative velocity, the speed is actually decreasing. This is where it becomes really tricky. Now let's take a look at the negative acceleration case. Let's take a look at this. If you go from -3, if you have -3 velocity, and the acceleration is negative, that means the next moment is going to be -4, -5, -6, because it's going to get smaller and smaller, more on the negative side. So velocity is decreasing. That makes sense. But notice, if it's -3 to -4 to -5, decreasing velocity because of the negative acceleration, -3, -4, -5, the speed, which is the positive value of the velocity, is going to go from +3, +4, +5, +6. So speed is actually increasing. This is a very important lesson, and you must memorize this in order to make your analysis during the AP exam efficient. Notice for a scenario, positive velocity scenario, depending on the acceleration, if it's a positive acceleration, it's increasing, regardless of the speed. Speed is always going to follow that, increasing, increasing. If the acceleration is negative, it will be decreasing, decreasing. It is when you have a negative velocity, this will begin to change. Velocity will continue to follow the sign of the acceleration. You see, acceleration is positive, velocity is increasing. Acceleration is negative, velocity is decreasing. However, speed at the positive acceleration for the negative velocity, it will be decreasing. Speed for the negative acceleration, for a negative velocity, will be increasing. So, let's take a look at our original problem. If you take a look at the original problem, and I should bring this back in here. Here it says, well, between 3 to 4.5, okay, what's going on? Well, let's take a look at it. Between 3 to 4.5, acceleration is negative. How do we know that? Because we know that from part A. A of 4 is negative value. Now, we then need to look at velocity. Well, what about velocity? Velocity velocity in between 3 and 4.5 is velocity positive, negative. Well, you can test one by putting, say, 3.5 into v. And what you will find out is that v is also a negative value. Now, if A is negative, V is negative, remember the determining factor to start out is velocity. Velocity is negative. Now, let's take a look at this. Velocity is negative. Now, speed is always positive. Velocity is negative. Our acceleration is negative. That means velocity will be increasing, velocity will be decreasing, and speed will be increasing. So, velocity will be increasing and speed, velocity will be decreasing and speed will be increasing based on the chart that we just developed. So let's take a look at our statement. Our statement says velocity is decreasing. Is that true? It is true. Speed is increasing. Is that true? It is true. So this becomes our justification. You can simply put that down and you can say they're both correct. Both 1 and 2 are correct. Okay? So that's our part B. Now we want to talk about part C. Part C. Going back to part C. Part C says, what is the total distance traveled? Total distance travel. Now this is very important. This is total distance travel between 0 to 4 seconds. It's very important to understand the difference between distance versus displacement. Now displacement is very simple. Displacement, you simply just take the definite integral, say from 0 to 4, v of t dt, and this answer comes out, it will be the displacement. Distance, however, is challenging to figure it out, because distance has to do with the moment when you stop, when you say from going from one direction and then you stop, right? And then the displacement from time 1 to time t1 to t2 is the definite integral between these 2 points. And then if the particle changes direction, then you have to find out the distance on this other end. So it's very important you figure out when does the particle stop. So we need to figure out when the particle stops. V of t is equal to sine pi third t. And you want to set it equal to 0. When you, and if you do the algebra, you will know that t is equal to 3 is where the velocity, the particle stops. So this means that you have to set up 2 different integrals. So the distance, the total distance between 0 to 4 with the moment at t equal to 3 when the particle stops, you have to take the definite integral from 0 to 3, alright, v of t dt, and you want to put the absolute value of that because it's possible that you have a negative displacement, right? And then add to another definite integral from 3 to 4, v of t dt, and by doing so, then you can go ahead and use your calculator, because this is number 3, and you can use your calculator to help you find the numerical value. And you can do the integral in 2 separate ways, and using the calculator, and then add the final results together. And the final results, based on the solution, you're gonna get somewhere around 3.432. Okay. Actually, I do want to make a quick revision. The actual answer is not 3.432. It's actually, if you use your calculator, it should give you 2.387. Okay, so let's move on to part D. Now, part D here says, if you go back to the problem again, the part D says, well, what is the position of the object at time t equal to 4? Position. Now we start out with the velocity equation. and velocity equation, and so position equation will be so x of t will be the integral or the antiderivative of the v of t dt. Now notice that this is an antiderivative rather than definite integral, precisely because we also need to utilize the initial position to help us to find the integration constant. So the initial, if you look back to the original problem, it gives you the initial position. You see, it's there for a reason. So we need to later on utilize this particular information. So I want to go ahead and write it down here. X of 0 is equal to 2 for me to use it later. So in this case, the integral of v of t, so in this case, we've done this earlier before. This is integral of sine pi third t dt. Now this gives you, and this is what we gotten earlier, I believe, and the integral of sine. So if you set u as pi third t, then du, this is using u substitution, then you get pi third dt, which gives you dt is equal to 3 over pi du. So this gives me integral sine u times 3 pi du. So now this 3 over pi can be brought to the front. So 3 over pi integral sine u du. So this gives us 3 over pi, and the integral of sine is negative cosine. And negative cosine, then we can end up with negative cosine u plus c, and u in this case is pi third t plus c. So this is our general equation. So we need to be able to come out, we need to find out what c is. This is very important. So I'm going to go ahead and add another piece of paper and so that I can finish this problem. So if we continue, let's just put it in together right here. So now if we can continue, then so right now we have a position equation, which is a general equation. X of t is equal to negative 3 over pi cosine pi third t plus c. Right. Now the issue is here is what that c is. What is that c? Well, we also remember, we know that x of 0 is equal to 2. What that means is when t is equal to 0, the whole thing is equal to 2. So we set 2 right here, and then we put 0 into t, and we want to find out what that constant is. Now, so this is 2, and this is negative 3 over pi. Now, 0 times pi third is 0, and cosine of 0 is 1. So here you have it. So c is equal to 2 plus 3 over pi. So now we have a very specific equation that we can work with. X of t is equal to negative 3 over pi cosine pi third t plus 2 plus 3 over pi. So finally, I want to find out what x of the question is, what is x at t equal to 4? Position at t equal to 4. So that's very simple. So we can put 4 into t. We end up with negative 3 over pi cosine pi third times 4 plus 2 plus 3 over pi. And remember, we earlier done this before. Cosine 4 pi third is negative 1 half. So you end up with negative 3 over pi times negative 1/2 plus 2 plus 3 over pi, and you end up with positive 3 3 over 2 pi plus 2 plus 3 pi. Now you can leave this as an answer if you like, or you can put it in your calculator, because this is problem number 3, which you will be able to enjoy using calculator, and so the answer is 3.432. And this concludes the solution, the overall solution for 2002 number 3.